Let me do this integral by two methods. Method one, start with substitution. I let t be 1 over x, which is the same thing as x is equal to 1 over t. Then my integral becomes arctangent t square and d 1 over t. The boundary has been changed from infinity to 0. Okay, now I didn't expand d 1 over t because I can use by parts right away. U dv. Right, so this one is equal to first let me change this one and I'll put a negative there. Okay, negative. Then uv right, becomes this is v, this is u t, right? Yeah, square. That's right. From 0 to infinity. I use this negative to switch it order. Then minus become plus. Well, I take it out, right? This is a minus. Sorry. Minus v du. V is 1 of x. Okay. V is a 1 of x. Yeah. 1 of x. Du is the derivative of this one with respect to t. So this is 2 arctangent t and the chain rule. And then dt. Yeah. Then this one, when t goes to 0, infinity equal to 0, no problem. When x approaches to 0, so 0 over 0, that you L'Hopital's rule. I'll leave it for you to finish it by using L'Hopital's rule. So this is 0. Negative change to positive. And take 2 out. Okay. So this one is arctangent t and t squared plus 1 dt. Very good. Then I use a substitution again. I let the t be tangent theta. So theta is equal to arctangent t. So this is equal to 2. And this is theta. This is tangent theta. This t squared is tangent square plus 1 is secant square. dt is a secant square theta d theta. So the boundary has been changed from 0 to half pound. Yeah. So this becomes 2 theta over tangent theta. Tangent theta is a cotangent, right? Cotangent. All right. Then this one is equal to 2 theta. Cotangent theta d theta is d log sine x theta. Yeah. Then I can use by parts again. So this was 2 uv, right? uv, u and v, yeah, from 0 to half pi, minus v du. V is this log sine theta. Du is d theta. Okay. So this when you go to 0 is no problem. No. When you go to half pi, no problem. This is 0. When it goes to 0, it's 0 times infinity. Then you use L'Hopital rules again. So I'll leave it for you. So if you go 0 minus 2 natural log. Well, I'm not repeating this integral. I do have a video showing this integral is equal to negative pi over 2 log 2. So the link is below. You can see the detail. Okay, I'm not repeating here. So the result is equal to pi log 2. 1. This is method 1. Method 2. Second method, the integral arctangent 1 of x squared dx. All right, I start by parts right away. This is u, this is dv. So u is arctangent 1 of x squared. So u times v is, this is v, this is u, and minus v du, integral v is x, du is the derivative of this one with respect to x. So it is equal to 2 arctangent 1 of x multiplied by the derivative of arctangent, this one, right? So this is equal to 1 over 1 of x squared. And the chain rule, the derivative of 1 of x squared is a negative 1 of x squared. And then times dx. Right? Yeah, that's by parts. When x goes to 0 is no problem. When x goes to infinitive, this is in 0, this is in infinitive. Infinitive times 0 is in determinate form. Use L'Hopital's rule. I'll leave it for you. And this one is equal to negative, positive. This is negative, this is negative. 2. And I write x first. Right? This is arctangent 1 of x. Yeah. For this, I multiply x squared both top and bottom. This is 1. This is x squared plus 1 dx. Yeah. So this is equal to 2 integral arctangent 1 of x x x over x squared plus 1 and then dx. That one could be written as arctangent 1 of x. This is d log x dx squared plus 1 divided by 2, right? Because this is x only. See, the chain rule is 2x. All right, now 2 cancel out. This by parts udv. So is equal to arctangent 1 of x times log x squared plus 1 and 0 to this. And the minus integral v du. V is this. Du is this one derivative with respect to x. So this is 1 plus 1 of x squared, 1 chain rule. Very good. When x goes to 0, no problem. It's a 0 times half pi. When x goes to infinity, that's infinity. This is a 0. I use L'Hopital's rule. So I leave it for you. So this is 0. Negative, negative become plus. And this becomes integral log x squared plus 1 over x squared plus 1, right? After this one simplified. And then dx. Then I use substitution again. Let x be tangent theta. So dx is secant square theta d theta. So this becomes integral. This is a log secant square. Yeah. This tangent square plus 1 is a secant square theta. And the dx is secant square theta d theta. So secant square cancel out. Now let me put a boundary first. This is 0, right? When x equals 0, when x equals infinity, that is half pi. This is a cancel out, so it becomes integral half pi log secant square theta d theta. This 2 could be written here. Log secant. Log secant is a negative. Log secant is a negative log cosine, right? So this is cosine theta, d theta. Well, I have a video showing this, right? This log sine x dx, well, which is equal to negative pi over 2 log 2. Now I have a video showing this, so the link is below. You can see it. And here, this one, if I use x is equal to half pi minus t, and this one equal to natural log of cosine t, right? And negative dt. and this becomes half pi to 0. So this one is the same as here, changing the negative right into the log of cosine t dt. So in other words, this is equal to that. And I have a video for this, so I'll get the same result of that. So this is minus 2 times negative half pi log 2. So it's equal to pi log 2. Wow, it's very good. So I've shown two methods. Thank you for your watching.